Now we're moving on to the topic of consumer choice, and we're going to be developing a conceptual apparatus for handling the choice-based approach of consumer choice. Now let's quickly define the concepts of commodity space and commodity vector and consumption set. So the framework here is we have a consumer in a market economy, and what do we mean by market economy? We mean that the consumer is facing goods and services that are available for purchase, and we refer to these goods and services as commodities, and we have L commodities, so the number is finite, and we can use an index to refer to them. So for example, XL would be the amount of the Lth commodity, for example, that the consumer might be purchasing. So the commodity space, let's just write this. Commodity space is simply a Cartesian product, RL, which is basically all the possible combinations of commodity amounts that are being consumed or purchased. And a commodity vector is going to be a list of the amounts of the different commodities. So we can simply write this vector, which is going to have L entries all the way to XL. And that's because we have L commodities. Now, we may restrict ourselves to a subset of the commodity space to the extent that consumption choices might be limited by physical constraints or institutional constraints or other kinds of constraints. So we're going to be considering the consumption set, which is simply going to be a subset of the commodity space. And so we can formally define this consumption set X. First of all, we're going to be considering only non-negative amounts because it doesn't make sense to really speak of negative consumption. And so this consumption set here is simply the set of consumption vectors or commodity vectors such that each entry in the vector is non-negative. And we do this for all commodities. Now these commodities are not free. They are available for purchase at a particular price, and we assume the price is known. And so we can formally represent the price system as by simply using a price vector. How many entries? Well, there are L commodities, so there are L entries. And each entry is the price of the Lth commodity. Now, given the particular wealth W, which the consumer possesses, we can define a budget set B, given this price vector and given W, which is simply the set of all consumption bundles that the consumer may afford, right? So we can simply write this budget set as the set of commodity vectors such that the price of this bundle is less than or equal to the consumer's wealth. Now, you'll note that this PX here, this product, is the product of two vectors. the price vector here is going to be 1 by L. The consumption bundle here is going to be L by 1 in terms of the dimensions. So we end up with a scalar, which makes sense since we're comparing this scalar to the wealth of the consumer. Now we can move on to defining the concept of the Walrasian demand, which basically assigns a set of consumption bundles that are chosen from a particular budget set. So we write that the Walrasian demand X, given the price system in place P and the consumer's wealth W, is simply a set of chosen consumption bundles. So it's going to be a vector listing the amounts of each commodity being chosen given the price system and the wealth. So we have again L entries. Now this is interesting here because the question is this single valued? Now, if we assume that there's only one such vector being chosen from a particular budget set, then yes, the answer is yes, and we have a Walrasian demand function. On the other hand, if we want to keep this general to accommodate for the possibility that the consumer may be choosing multiple bundles, remember the choice-based approach is potentially general enough to accommodate for the possibility that the choice rule assign multiple bundles. So we are allowing potentially for the possibility that the consumer choose over time different things from the budget set. So if we want to keep it general, this has to be a correspondence, but for convenience sake, for the remainder of the discussion, we really are going to be focusing on the Walrasian demand function. Now this function is mapping from R L plus 1 from the Cartesian product R L plus 1. Why L plus 1? Well, we have L prices, right? Because we have L commodities, and then we have the wealth amount. So that's plus 1, and we're mapping into RL because we are assigning to the price system and the wealth, we're assigning a particular consumption vector with L commodities, L entries. Now we can normalize either for prices or for wealth, but let's just assume we're normalizing for prices, and we can now have a function that maps from RL into RL if we normalize prices. Now one assumption that is often made about the Walrasian demand function is that it satisfies Walras law. And Walras law is essentially the idea that the consumer is expending all his wealth. So the cost of the bundle being chosen, given a particular budget, is equal to, and just equal to, W. Now the textbooks, Mascalel, Winston, and Green's interpretation of this on page 23, on section 2E, definition 2E2, and I'm reading from the textbook here, is that the wealth of the consumer is to be understood as the wealth as defined over a lifetime. This is what the textbook is saying. Walras law should be understood broadly. The consumer's budget may be an intertemporal one, allowing for savings today to be used for purchases tomorrow. What Walras law is saying is that the consumer fully expends his resources over his lifetime, which I think raises the interesting question of how to define the consumption vector. Is it also defined over a lifetime or over a different time period? And I don't think it's exactly clear in the textbook how you sort of resolve this. On page 18, reading from the textbook here, they seem to be defining the consumption bundle as defined over some time period, but it's not exactly clear which one. So I'm reading here, although commodities consumed at different times should be viewed rigorously as distinct commodities, in practice, economic models often involve some time aggregation. One commodity might be bread consumed in the month of February, even though in principle, bread consumed at each instant in February should be distinguished. So there is some acknowledgement here that some time aggregation might be needed, but it's not exactly clear how that's done and how you reconcile that with the statement that Walras law is to be understood over a lifetime. So I just wanted to raise this as food for thought. Something interesting to think about when we're defining these vectors and variables.